In this example, we're asked to use transformation of graphs to sketch the graphs of y sub 1, y sub 2, and y sub 3. We're also asked to check by graphing in an appropriate viewing window of a calculator. We see that y sub 1 is equal to x squared minus 4, y sub 2 is equal to 1/4 x quantity squared minus 4, and y sub 3 is equal to 3x quantity squared minus 4. Before we attempt to answer the question, let's review horizontal and vertical stretching and shrinking. So I'll simply go into the multimedia library. I'll look within the PowerPoint section, section 2.3. And it says that the vertical stretching of a graph, if a point x comma y lies on the graph of y is equal to f of x, and f of x would be your originating function, such as a linear function, a quadratic function, an absolute value function, or anything of the like. Notice in this example they're giving us f of x is equal to the absolute value function. And it says that the graph of y is equal to c times your originating function. If c is greater than 1, then you have the graph of a vertical stretch. So notice for each one of these following examples, we're given the root function, which is the absolute value of x. In the second example, we're multiplying the absolute value of x by 4.3, which is a value greater than 1, which would result in a vertical stretch. Y sub 3 is 2.4 and y sub 4 is 3.2. Okay, notice they give you the graphs for each one respectively. If we take a look at vertical shrinking, the vertical shrink is in the form y is equal to c times f of x, but notice that in this particular instance c is greater than 0 but less than 1. So here they're using the cubing function x cubed. So notice for y sub 2 they multiply x cubed by 0.1, and notice that 0.1 is in the interval from 0 to 1. For y sub 3 they multiply by 0.5, and for y sub 4 they multiply by 0.3. Each one will result in a vertical shrink of the graph x cubed. Next, we'll take a look at horizontal stretching and shrinking. And here we have the function in the form y is equal to f of x. But notice for a horizontal stretch or shrink, we now have y is equal to f of c times x. If c is greater than 0 and less than 1, this will result in a horizontal stretch. If c is greater than 1, this will result in a horizontal shrink. Although there are no examples on the graph, I'll generate some examples by using the graphing calculator, and I'll go back to the vertical stretching slides, and I'll use this absolute value function. Notice that this 4.3 times the absolute value will result in a vertical stretch. However, in my calculator, if I were to enter the absolute value of 4.3x, this will result in a horizontal shrink because the number I'm multiplying x by is greater than 1. So I'll graph, and this would be a horizontal shrink. If I wanted a horizontal stretch, notice that the number I multiply x by should be in between 0 and 1. So I'll go back to y equals. So I'll put in the absolute value of 0.1x. And this should result in a horizontal stretch. So note the differences on the two. Now if we go back to our homework problem, I'm going to use the quadratic function. So notice it has a vertical shift down 4 units. So my vertical shift is -4. For my next function, I have 1/4 x quantity squared minus 4. So in graphing my y sub 2 function, my vertical shift is -4. However, since I'm multiplying x by 1/4, this will result in a horizontal stretch. So my horizontal stretch is 0.25, which is 1/4. And for that third function, again, I'm going to use the quadratic function. My vertical shift is -4. And in this case, my horizontal shrink should be 3.